Hello and welcome to today's video. Today's video is for Advanced Geometry, Chapter 1, Section 9, Perimeters, Circumference, and Area. So we start out with some basic definitions. If we have a square with side length s, the perimeter is just 4s and the area is s squared. If we have a rectangle with base b and height h, the perimeter is 2 of the bases plus 2 of the heights, and the area is just the base times the height. And if we have a circle with radius r and a diameter d, the circumference is just pi times the diameter, or a lot of people like to do 2 times pi times r. And the area is just pi times the radius squared. So most of us are very familiar with those, so some basic definitions. So your pool deck is 15 feet wide and 20 feet long with a 3-foot wide deck surrounding it. You want to build a fence around the deck. How much fencing will you need? So for this one, they're asking for fencing to go around the deck. So they want to know the perimeter. The only hard part about this problem is even though it's 15 from here to here, we've got an extra 3 feet on both sides. So this is really 21 feet. And the same for this direction. This is 20 feet, but that's 3 feet up there, that's 3 feet down there, so really we have 26. And then once we do that, the perimeter formula is easy. We've got 2 of the lengths and 2 of the widths or bases and heights. So it's going to be 42 plus 52 is 94 feet. We have 2 postulates. So the first one, if 2 figures are congruent, then their areas are equal. So for this one, this is the congruent figures postulate. So the second one says the area of a region is the sum of its areas of its non-overlapping parts. So if we have a figure that's not necessarily a square or a rectangle or a circle, what we can do is we can find its area if we can break it up into smaller figures that we can find the area of, as long as those figures do not overlap. So we can take all the small areas, we can break it up into, find those areas, and the area of the region is the sum of those areas of the parts that do not overlap. So this one I like to call the sum of areas postulate. And like all of these, you notice these are not book named postulates, so we're naming them ourselves. As long as you have the main parts, like some areas, then you're okay with naming it. So if you called it the areas of, some postulate or something like that, I'd be fine with it. So the next example, it's not too interesting of an example on its own, but you notice I've drawn it several times because what I want to do in class is I want to see all the different ways that we can think of breaking up this figure. So if you have some interesting ways, make sure you share them. Tomorrow, if I forget, remind me. But basically, we want to find the area of the figure at the right by breaking it up into non-overlapping parts. Okay, so we'll do that one in class. And that's it for today's notes. Thanks for watching. Have a great day.